Hey friends, welcome back to the channel. In this video, we will learn how to graph trigonometric functions of sine, cosine, and tangents between 0 degrees and 360 degrees. In these trigonometric graphs of function, x-axis values of the angles are in radians, half of pi radians 90 degrees, pi radians 180 degrees, 1.5 pi radians 270 degrees, and 2 pi radians 360 degrees. Minus 1 to 1 on the y-axis for the value of the function at each given angle. First of all, we try to draw a graph of sine function. We can use a table of values to plot selected points between 0 degree and 360 degree. With the values from the above table, we can have an idea of what the graph of trigonometric functions look like. When x equals 0 degree, sine x equals 0. Plot the point at origin. As we increase x to 90 degree, sine x increases to 1. As we increase x further, sine x decreases. It becomes 0 when x equals 180 degree. It then continues to decrease and becomes minus 1 when x is 270 degrees. After that, sine x increases and becomes 0 again when x reaches 360 degrees. More degrees are needed to help in graphing a smooth curve for the sine function. With the help of calculator, sine 30 degrees equals to 0.5. Plot the point on the graph. Sine 45 degrees equals 0.707. Sine 60 degrees equals 0.866. Sine 120 degrees equals 0.866. Sine 135 degrees equals 0.707. And sine 150 degrees equals 0.5. Graph the function by connecting all the points with a smooth curve. A sine function has an up-down curve. We can then extend the graph to the right and to the left because we know that the graph repeats itself every 2 pi radians or 360 degrees. Repeat the same shape from negative infinity to positive infinity on the x-axis. For the graph of cosine function, a table of values to plot selected points between 0 degree and 360 degrees. When x equals 0 degree, cos x equals 1. Plot the point at 0, 1. As we increase x to 90 degrees, cos x decreases to 0. As we increase x further, cos x decreases. It becomes minus 1 when x equals 180 degrees. It then continues to increase and becomes 0 when x is 270 degrees. Cos x continues to increases and becomes 1 again when x reaches 360 degrees. Complete the other values of the table and plot the points on the graph. Cos 30 degrees equals to 0.866. Cos 45 degrees equals 0.707. Cos 60 degrees equals 0.5. Cos 120 degrees equals minus 0.5. Cos 135 degrees equals minus 0.707. And cos 150 degrees equals minus 0.866. Graph the function by connecting all the points with a smooth curve. Cosine is just like sine, but it starts at 1 and heads down until pi radians 180 degrees and then heads up again. The graph extends to the right and to the left because the graph repeats itself every 2 pi radians or 360 degrees. Graph repeat the same shape from negative infinity to positive infinity on the x-axis. For the graph of tangent functions at 90 degree and 270 degree, the function is officially undefined because it could be positive infinity or negative infinity. When x equals 0 degree, 180 degree, and 360 degree, Tangent x equals 0. Plot all the points on the graph. Now, check for the others. Tangent 30 degrees equals 0.577. Tangent 45 degrees equals 1. Tangent 60 degrees equals 1.732. Tangent 120 degrees equals minus 1.732. Tangent 135 degrees equals minus 1. And tangent 150 degrees equals minus 0.577. The tangent function has a completely different shape. It goes between negative and positive infinity, crossing through 0, and at every pi radians 180 degrees. Graph the tangent function. The graph extends to the right and to the left because the graph repeats itself every pi radians or 180 degrees. Graph repeats the same shape from negative infinity to positive infinity on the x-axis. Keep in mind of the three basic graphs of the trigonometric functions: sine function, cosine function, and tangent function. To sketch the trigonometric graphs of the functions, we need to know the amplitudes and periods. Amplitude is the maximum distance measured from the central line for sine and cosine functions. For these sine and cosine functions, both have an amplitude of 1 because the graph goes 1 unit up and 1 unit down from the midline of the graph. Tangent has no amplitude as its curve tends to infinity. Period is the interval of one complete cycle. Sine function and cosine function have a period of 360 degrees. The period of sine and cosine functions equals 2 pi. Tangent has a period of pi radian. Now, we learn how to sketch the graph of trigonometric functions of y equals a sine bx plus c, y equals a cos bx plus c, and y equals a tangent bx plus c. What are the effects of changes in constants a, b, and c on the graphs of trigonometric functions? A. When a changes, the maximum and minimum values change. B. When b changes, the graph will be compressed or expanded. C. When c changes, the graph will move vertically up or down. In a trigonometric function, the value of a affects the amplitude of the function. The value of b affects the period of the function, and the value of c affects the positions of the graph of the function. A is the amplitude of sine and cosine function. Tangent function has no amplitude due to its curve tends to infinity. Sine and cosine function have a period of 360 degrees. Therefore, the period of sine and cosine functions equals 360 degrees divided by b. Tangent has a period of 180 degrees. The period of tangents equals 180 degrees divided by b. How to sketch the graph trigonometric function with the help of the corresponding graph? Y it says when amplitude changes, the maximum and minimum values change. For the function y equals 2 sine x, this function has an amplitude of 2. The graph goes 2 units up and 2 units down from the midline of the graph with periodicity of 360 degrees. For the function y equals 2 cos x, it has an amplitude of 2, a maximum value of 2 and a minimum value of minus 2 with periodicity of 360 degrees. For the function y equals 3 sine x, this function has an amplitude of 3. The graph goes 3 units up and 3 units down from the midline of the graph with periodicity of 360 degrees. Let's have a look of the graph with different amplitudes. Y equals 2 sin x, y equals 3 sin x, y equals 2 cos x, and y equals 3 cos x. When b changes, the graph will be compressed or expanded. Let's start with the function y equals sin 2x. For this function, the value of amplitude a equals 1. The graph goes 1 unit up and 1 unit down from the midline of the graph. Period is the interval of one complete cycle. For sin 2x, its period 360 divided by 2 equals 180 degrees. This means it completes one cycle in 180 degrees. Let's see how sine compresses and forms a graph of sin 2x. It has two waves within 0 and 360 degrees. This is how the graph of sin 2x is formed. Y equals cos 2x. For this function, the value of amplitude a equals 1 and a period of 180 degrees, 360 divided by 2. Cos 2x completes one cycle in 180 degrees. It has two waves within 0 and 360 degrees. The graph of cos 2x. Tangent has no amplitude because its curve tends to infinity. The period of tangent 2x equals 180 divided by 2, that is 90 degrees. Tangent 2x completes one cycle in 90 degrees. Let's see how tangent compress and form a graph of tangents 2x. At 45 degrees, 135 degrees, 225 degrees, and 315 degrees, the function of tangent 2x is officially undefined because it could be positive infinity or negative infinity. Graph the tangents 2x. For the function sin half x, its amplitude equals 1 and period equals 360 divided by 1 over 2. Its period is 720 degrees. The sine graph will be expanded. Sin half x has half wave between 0 and 360 degrees. Let's have a look of the graph with different periods between 0 and 360 degrees. The function y equals sin x has one wave. Sin 2x has two waves. Sin 3x has three waves. Sin half x has half wave. Sin 4x has four waves. And sin 1.5 x has 1.5 wave. What happens when the amplitude of a sine graph is negative? The function y equals minus sin x. The graph flips upside down, or it can be said a reflection in the x-axis. Same to the graph y equals minus cosine x. The graph flips upside down. And y equals minus tangent x, the graph reflects in the line of x-axis. When c changes, the graph will move vertically up or down. Let's practice what we learned in the above paragraph with view of trigonometry functions graphing questions. Sketch the graph of y equals 2 sine x plus 1. Sketch the graph of 2 sine x. Plus 1 means that the graph moves 1 unit upward. Sketch the graph of y equals cos 2x minus 2. Sketch the graph of cos 2x. Minus 2 means that the graph moves 2 units downwards. Sketch the graph of y equals minus tangent x plus 1. Sketch the graph of minus tangent x. The graph flips upside down. Plus 1 means that the graph moves 1 unit upward. Sketch the graph of y equals minus 2 sine 3x plus 1. Sketch the graph of minus 2 sine 3x. The graph flips upside down with 3 wave width and amplitude of 2. Plus 1 means that the graph moves 1 unit upward. That's all for this video. I want to thank you for going through this lesson with me. I will see you in the next one.